Good morning, students. This is the new topics. Topic 3, bonding and structure. Topic A also sub topic. Topic 3, A, ionic bonding. B, covalent bonding. C, shape of molecules. D, metallic bonding. And E, solid lattices. Okay, today ionic bonding. Ionic bonding, you know the nature of ionic bonding. You know how ionic bonding is formed. Do you know these things? How ionic bond is? What is bond? What is bond? What is bond and what is ionic bonding? Bonding is attraction. This like family bonding. We all family members live together for a bonding. Family bonding is the attraction. This bonding. Here is chemicals also bonding present. But the chemical they form different type bondings. One type of bonding is ionic bonding, covalent bonding, metallic bonding. Okay, today I discuss ionic bonding. Ionic bonding form positively charged different oppositely charged ions. Two oppositely charged ions, positive charged ions and negative charged ions. The attraction force between the oppositely charged ions is called ionic bonding. This is the attraction force, electrostatic attraction force. All bond is a electrostatic attraction force between electrostatic attraction force. I think either say atoms, ions, or electrons or nucleus. But in ionic bonding, the electrostatic attraction force between oppositely charged ions, positive charged ions and negatively charged ions. This is the ionic bonding between sodium and chloride ions. Sodium ions and chloride ions. So what is ionic bonding? Say someone. What do you mean by ionic bonding?
Electrostatic attraction between ions or atoms.
Atoms? Not atoms.
Attractions.
Not atoms. If you write atom, I'll cut mass.
Ions.
Ions. And this ions must be oppositely charged ions, positive charged and negative charged ions. Okay, you can write the electrostatic attraction force of attraction force between oppositely charged ions. Here you can write between positive charged ions and negative charged ions, or you can write oppositely charged ions. Okay, this is the ionic bonding. How ionic bonding is formed? Okay, how you see there the covalent bonding definition here also. This is also electrostatic attraction force of attraction between the nuclei of the two atoms and pair of electrons in two overlapping atomic orbitals, one from each atom. Okay, this is the difference between ionic bonding and covalent bonding. Here the attraction force between the nuclei of the two atoms and pair of electrons in two overlapping atomic orbitals. Okay, now how ionic bond is formed? Like look at here example, sodium chloride can be formed by burning sodium in chlorine. Look, sodium is burning in chloride, chlorine forms sodium chloride. We can represent the reaction that occur by two ionic half equation. Okay, sodium lost one electron. Why do sodium lost one electron? Can you say someone? Why do sodium lost one electron? This is the sodium. What is atomic number? What is atomic number sodium? What is atomic number sodium?
11.
Okay, atomic number means proton number. So atomic number 11, so proton number 11. We know in a atom number of proton and electron are same because atom is electrically neutral. So electron number is 11. Okay, this electronic 281, it lost one electron. So it will how many electron will lost in the outermost shell? It has sodium has one electron. Okay, so sodium will lose how many electron? One electron will lose. We write this only outermost shell. Sodium this is the sodium this is the first shell, second shell, and now this is the third shell. You draw this thing using by compass. Here it is not possible using compass. So first shell is 2 electron. Okay, this is the dot cross diagram. This is the dot. I will here draw dot cation. Okay, and this look at sodium first shell 2 electron, second shell 8 electrons, second shell 8 electrons, sorry, and sorry, it is not possible. Drawing is not easier here. 8 electrons, and in the outermost shell 1 electron. So how many electron will lose? Sodium will lose in the outermost shell 1 electron. So it lost minus 1 electron, and then it become sodium positive charge, 1 positive charge. Why this? This is proton number is remain same 11, and electron number, because 1 electron lost, electron number is 10. So here proton is proton 11, electron is 10. So proton number is more, so it is positive. How more? 1. So 1 positive. This way form charge here. So this is this wise it form 1 positive charge. Okay, and chloride, chlorine, this the chlorine, 17 electron, 287. In the outermost shell, if it gain 1 electron, it will gain octet, so it will gain 1 electron. So it will be chloride minus, because it is electron number is 17, proton number is 17, and electron number is 17. When it gain 1 electron, its proton number remain 17, but electron number become 18. So here electron number is more. How more is 1? So electron number is more, so negative, and 1 more is 1 negative. So this way positive charge and negative charge at ions are formed. Okay, this is the dot cross diagram, dot diagram of, and chlorine. Chlorine, I will draw the cross diagram. This is the chlorine. I will draw this chlorine, like chlorine chlorine. You know these things in the a IGC label. This is the cross. This is the cross. At first here I use draw, and this is the here is a 7 electron for chlorine. So it will gain 1 electron to fill octet, to gain the noble gas electronic configuration. So it will gain 1 electron. If it is easier for loss electron for sodium, it can lose electron, so it will lose 1 electron. It is difficult to lose 7 electron. It is easier gain 1 electron, so it gain electron, chlorine, and sodium loss electron. So here look this how so 2 sodium atom gain loss 2 electrons from 2 sodium ions, and 2 chlorine atom gain 2 chlorine electrons, become 2. Here written only outer shell electron in a sodium. Write that cross diagram, only outer shell electrons. Outer shell. Look, this is sodium. Sodium, what is outer shell electron? Only 1. They have written here sodium only outer shell electrons. Outer shell electrons, sodium 1 electrons. Only 1 electron they have written. Only 1 electron. Here you can write outer shell electron only or 3 shells. It is not. It is foolishness if you draw only all shell. You will draw only outer shell. It is enough. Okay, this is the sodium dot cross. Okay, here was we have seen 2 sodium atom. So I am drawing another sodium atom. Okay, look, next is here chlorine atom, 2 chlorine atom. 2 chlorine atom here is also formed. He is formed by covalent bond. So it is written this way, chlorine atoms. Then it is formed this way. You know, I will not draw more things. This is the dot cross diagram showing the formation of sodium and chloride ions. Okay, you have a you can draw the dot cross diagram of chloride ions showing the outer electrons only. Can you able to draw this thing? Class work. Draw the dot and dot and cross diagram. Okay, this is not, you draw this thing. Okay, draw this calcium react with fluoride ions, form ionic compound of calcium fluoride. Use dot cross diagram to show the electronic changes that occurs in this reaction. Draw and submit to my WhatsApp number. Hello student, are you listening me? Oh, it is time.
Yes, sir.
Okay, draw the quickly draw and submit to my WhatsApp number.
Sir? Sodium reacting with
Calcium atomic number, are you asking atomic number? 12. Oh no, 20.
Say?
I didn't understand your question. Say again.
Yes, I was just asking about the questions.
Okay, this is the question. Look, calcium reacted with fluorine form ionic compound of calcium fluoride, and you use dot cross diagram to show the electronic change that occur in this reaction. Okay, this is the question. Okay, my hair I submitted here. What is this? Okay, it is not in yesterday class. Fluoride atoms. Calcium. Fluoride 7 electrons. Why didn't you use cross? You have also used dot. Where is your cross?
Sorry, sir.
It should be dot and cross. Okay. Okay. It's done. It is wrong. It is wrong. You have drawn this. The not. You have written here. It is not covalent bond. You are sharing electrons. It is not covalent bond. It is wrong. Sorry, your answer is wrong. It is not covalent bond. It is between positive and negative charge. Ionic bond is formed. You have written sharing here. Your answer is sorry wrong. Have you understood? Where is it?
Yes, sir.
Now this Tamara, what have done? This look. Wow, excellent. Have you seen? Done well. Excellent. Tamara, this is the calcium 2822 2882. Outer shell electron is 2. So 2 electrons in fluorine. Yes, excellent. I do these things. Copy, paste, and write also. Look what I am doing. Killing time also. I have also class here. Okay. Have you seen these things? Okay, I'll post this in the your yes. Wait, this is I am saving this one, and I'll post these things in the in our group. Okay, 10 minutes remaining for this class. This is busy due to the is here also I am using which things using I am using here different many software I am using taking this class. For this reason is so busy. For otherwise if I use only 1-2 software, computer will work quickly, but here work is slowly due to different software. Zoom, due to Zoom here. Okay, you are watching my what I download everything here. It is digital system and everything can be shown here. Okay, so I am using here which things I use right not my these things. Okay, okay, correct, excellent. I to give it right mark. For this reason I do this. Okay, excellent. Tamara this one. Okay, excellent. Okay, now I am going to my topics, today's class topics. have you seen these things? Okay, this way form the so ionic bonding we have done this thing, how to write dot cross diagram. Now we'll go to another matters. Ionic bonding occur in a solid materials consisting of a regular array of oppositely charged ions extending throughout the giant lattice network. It is a giant lattice network, so it is a lot of bond form, consist a lot of bonds, so it require high amount of energy. So ionic bonding containing compound have high melting point, high boiling point. The most familiar ionic compound is sodium chloride. This is a table salt. This is a regular array of sodium ions and chloride ions as shown. This is the one sodium and chloride. This is a one array. This is the another array. This is the another way. This way form a, like this is a one building unit, like another type 1 and fourth story building, like another second floor, ground floor this way, then first floor this way, third floor this way, and this way it form a giant lattice structure. Here is a all things is regular array form. One like this is a I draw these things. Do you understand what is regular array? Regular array, do you know, do you understand what I will not explain more. If you understand regular array, I will not understand, I will not explain more. I'll go to the another topics. Okay, these things okay, where's our other student? Hello students. Okay, now I am class আছে না আর okay, who are there here? Tamara not joining. Okay,
Sorry, sir, my Wi-Fi turned off.
Okay, no problem. I am facing some problem also. Okay, so what do you mean? Do you understand what do you mean by regular array? মানে সব সময় যেমন একটা রুমের প্রত্যেকটা ইউনিট সমান সমান থাকবে, মানে এই ক্ষেত্রে কি হবে না, if you just this is the regular array. This arrangement, this is called lattice. For this reason, ionic compound have high melting point and boiling points. Okay, like this, the sodium and fluoride. What is the ions energy required to separate the ions? Fluoride and lithium and fluoride, 1031. Now sodium and fluoride, 918. Potassium and fluoride, 817. Rubidium and fluoride, 783. So we have understood the smaller charge, cation charge. Smaller charge ions have high electron density, charge density. For these reasons, it has more energy required. So more energy charge energy required. So for then fluoride decreases, bromide decreases, and iodide decreases, lithium iodide. So we have understood from this, for the ions of the same charge, the smaller ions, the more energy is required to overcome the electricity attraction between ions and to separate them. So smaller ions, same charge, this is the lithium 1 positive charge, sodium 1 positive charge, potassium 1 positive charge, rubidium 1 positive charge. So same charge, the smaller ions, more energy is required to overcome the electricity attraction force because more charge contained in a ions. Look, the lattice energy for the lithium fluoride is 1031 kilojoule per mole. The equivalent energy for magnesium fluoride is 2957. It is double. The radius of magnesium ions is 0.072 nanometer, is very smaller to the radius of the lithium ion, 0.004. The increase in charge, so charge increase in the magnesium ions, more charge because it is smaller. When charge, more charge, so it becomes smaller. This, look, it is 0.072 nanometer, it is 0.074 nanometer lithium, and magnesium is 0.072, it is 0.074. So the magnesium is smaller, so in more charge, so more charge density. So the increase of charge magnesium ions compared to the lithium ions result in a significant increase the strength of the ionic bond. So if charge increases, so charge density increases, so it becomes strong bond, ionic bonding. In general, we can show the evidence of the existence ions by two way, by electrolysis. Here ions will move to negative ion, positive ion move to the negative electrode, and negative ions move to the positive electrode. So here this positive ions move to the negative electrode from sodium atom, and a negative electron ions move to the positive electrode from chlorine atom. The explanation for this phenomenon is that the positive sodium ions migrate to the negative electrode, where gain electrons and become sodium atoms. So here is from sodium atoms, and the negative chloride ions migrate toward the positive electrode. They lost electrons and becomes chlorine atoms. So this is from overall reaction. Like we can demonstrate the movement of ions by passing direct current through copper to chromate 6. This the copper to chromate 6, color is green. Okay, here two ions, copper ions and chromate ions. Positive is copper ions and chromate ion. When we pass current here. So copper 2 ions migrate to the negative electrode and become this electrode turns blue. This electron turns blue, and chromate ion migrate to the positive terminal, and the solution turns yellow. So we can show the evidence of ions by passing a direct current using electrode by electrolysis process. And another process to show the existence of ions, this electron density map. Electron density map show the ions, the represent the, like this is the electron density map of sodium chloride. This is the form, the electron density form for the cations and anions form different map for the cation and anions. Different map show from this the electron density map of sodium chloride produced by X-ray diffraction pattern. So it for ionic compound form separate map for cation and anions. So what is electron density map? Electron density map show the distribution of charge, and electron density map show the lines which represent area of equal electron density. So here is the electron density map for the ionic bonding. Ionic bonding, the cation separate, anion separate, ionic bonding. And for covalent bonding, this is the bond form, but it is not separated. It is more electronegative element, like which one is electron is this way, not separated for covalent bonding. And ionic bonding electron density map is for cation and anion separate. Okay, have you understood these things? Okay, I'll give you assignment here. You submit these things. Okay, you will understand everything. Okay, thank you for joining today's class.
Thank you, sir. Thank you, sir.
Okay, I'll give you an assignment. You submit by 25th February. Okay, thank you.
Okay, sir. Assalamualaikum, sir.
Walaikum assalam.